let's say we need to write all the terms in the expansion of 2 plus x squared raised to the power of 4. To do this, the first thing I would suggest is to rewrite this as 2 plus x squared in parentheses, all of which is raised to the power of 4. And this will allow us to avoid making mistakes with powers further on down the line. Now, to write all the terms in the expansion of 2 plus x squared raised to the power of 4, we can fall back on the formula for binomial expansions, which states that a plus b raised to the power of 4 is equal to the sum from r equals to 0 up to 4 of the product of the binomial coefficients for r with a raised to the power of 4 minus r and b raised to the power of r. Now, comparing a plus b raised to the power of 4 with 2 plus x squared raised to the power of 4, we can see that the only difference is the fact that we have replaced a by 2 and b by x squared in parentheses. Consequently, 2 plus x squared raised to the power of 4 will equal to this sum, in which we replace a by 2 and b by x squared in parentheses. And that would look like this. It should equal to the sum from r equals to 0 up to 4 of the product of the binomial coefficient for r with 2 raised to the power of 4 minus r and x squared in parentheses raised to the power of r. Now that we've done that, we are ready to write all the terms. And to do that, we need to use the expression that I'm currently boxing in green, just to the right-hand side of the summation symbol. Now, since this binomial is raised to the power of 4, it will have 4 plus 1, which of course equals to 5, and that's 5 terms in the expansion. And to find each of the terms, we need to rewrite this expression that I've boxed in green, successively replacing r by all the values between 0 all the way up to 4. In other words, we need to rewrite this expression for r equals to 0 to 1 to 2 to 3 and to 4. And we can see there that that will lead us to having 5 terms. So let's go ahead and do that. This will equal to the case where r equals to 0, that would be 0 times 2 to the power of 4 minus 0 times x squared raised to the power of 0. We add to that the case where r equals to 1. That would be 1 times 2 to the power of 4 minus 1 times x squared raised to the power of 1. We add to that the case where r would equal to 2. That's 2 times 2 to the power of 4 minus 2 times x squared in parentheses raised to the power of 2. We add to that the case where r equals to 3, so that's 3 times 2 to the power of 4 minus 3 times x squared to the power of 3. And finally, we add to that the case where r equals to 4. And that's 4 times 2 to the power of 4 minus 4 times x squared in parentheses raised to the power of 4. We now have all 5 terms. Indeed, we can see we have 1, 2, 3, 4, and 5 terms in this sum. And now our job is to simplify this as much as possible. And a good starting point for that is to tidy up these powers of 2 that we see here. So rather than 2 to the power of 4 minus 0, we'll have 2 to the power of 4. Instead of 2 to the power of 4 minus 1, we'll have 2 to the power of 3, and so on. So doing that leads to the following. Done. Now the next thing we can do to simplify this a little further is to use the fact that any number raised to the power of 0 is equal to 1. Consequently, x squared raised to the power of 0 equals to 1, and 2 to the power of 0 equals to 1. Another rule that we can use is the fact that any number raised to the power of 1 is equal to itself. So we can rewrite this x squared raised to the power of 1 as being x squared, and this 2 to the power of 1 will simply equal to 2. So, keeping those in mind, we can rewrite this sum as Okay, that's starting to look better, but we can simplify this further. Indeed, we have these powers of 2 here that we can calculate. And we have 2 to the power of 4, which equals to 16, 2 to the power of 3, which equals to 8, and 2 to the power of 2, which equals to 4. So using those results, we rewrite this sum as good. Now another thing we need to do is to take care of these powers of x squared. And to do that, we need to use an important law of exponents. Remember that x to the power of m raised to the power of n equals to x to the power of m times n. So for instance, if we have x to the power of 3, all of which is squared, that's equal to x to the power of 3 times 2, which equals to x to the power of 6. So, keeping that rule in mind, we can go ahead and simplify these powers of x squared. Indeed, we have x squared squared, which becomes x to the power of 2 times 2, which equals to x to the power of 4. We also have x squared to the power of 3, and that will turn into x to the power of 2 times 3, which equals to x to the power of 6. And finally, we have x squared to the power of 4, and that will be x to the power of 2 times 4, which equals to x to the power of 8. So we can now rewrite this sum as follows. It is equal to the binomial coefficient 4, 0 times 16 plus the binomial coefficient 4, 1 times 8x squared plus the binomial coefficient 4, 2 times 4x to the power of 4 plus the binomial coefficient 4, 3 times 2x to the power of 6 plus the binomial coefficient 4, 4 times x to the power of 8. Okay, we've now gone as far as we possibly could without calculating these 5 binomial coefficients, and so we now need to take care of them. But rather than diving onto the calculators or the formula straight away, remember we have some nice little tricks. The first and the last binomial coefficient will always equal to 1, so we can go ahead and replace both of those by 1. Secondly, the second binomial coefficient and the second to last binomial coefficient will always equal to the power to which the binomial was raised. So in this case, that's 4. So we can go ahead and replace each of those by 4. And so the only binomial coefficient we really need to calculate is the middle one. That's the binomial coefficient 4, 2. And I'll go ahead and calculate that at the top of this page. The binomial coefficient 4, 2 will equal to factorial 4 over factorial 4 minus 2 times factorial 2. That's equal to factorial 4 over factorial 2 times factorial 2, and that's equal to 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Now, looking at this, we can see that this 4 on the numerator will cancel out with the 2 times 2 on the denominator, and that leaves us with 3 times 2 times 1 over 1, and we can see that that equals to 6. So we can go ahead and state that that middle binomial coefficient equals to 6. And we're now in a position to write the final answer. Indeed, we can go ahead and state that 2 plus x squared, all of which is raised to the power of 4, will equal to 1 times 16, which is 16, plus 4 times 8x squared, which is the same thing as 32x squared, plus 6 times 4x to the power of 4, which will be 24x to the power of 4, plus 4 times 2x to the power of 6, which will be 8x to the power of 6, plus 1 times x to the power of 8, which will just be x to the power of 8. And there we have it. We've just written all of the terms in this expansion. There we go, everyone. I really hope that helped, and if it did, please hit like on this video and even subscribe to our channel, because that really does help us. I'll see you soon.